Hello.
Hi there, Mike.
Oh no, I can't hear you again. Shoot. All
Let's
right.
see.
Right, hang on. You know what? Now I can. My
Yeah.
volume.
Phew.
I know, right?
Um, yeah, that's a relief. Uh, cool. So are we, I assume you'll tell me, are we live right now?
We are live.
All right, fantastic. Well,
But we're not we haven't started the show officially.
got it. Okay.
Now's
Is
the
there
time where
more?
we chit chat a little bit. So what we do is we get the live stream going and then send out notifications to everyone so they can join in. Um, but we put out the notifications that the show really starts at noon.
Cool.
So no one is. What I can see here is we have no one from YouTube connected yet, but I can look on LinkedIn. Have you done a live stream before?
I have not actually. I've done, I've done some like YouTube videos for, like some marketing type videos, but not live. So new to me.
Well, the cool thing after this, we post this on our YouTube channel, and of course you can download it from there and use it for your marketing as well.
Awesome. It's fantastic.
Yeah. Um, so you said you're in Bloomington, Indiana.
That's correct. Yeah.
Is
Yeah.
that
So
University of Indiana's there, correct?
it is. Yeah. My alma mater. Yeah.
Is that or is the crew, the entire team there from Indiana?
It's a mix, but predominantly yes. Both founders of the company are based in Bloomington. And for anyone who's watching, I know we kind of jumped into it here, but the company I'm with is called Terran Robotics, and yes, we're based in Bloomington, Indiana. We're a construction automation company.
Gotcha. Did uh, did the entire team go to Indiana?
Um, no, let's see. We have two people on the team who went to IU. The founder actually went to Washington University in St. Louis, and
Okay.
uh, yeah, he's kind of the technical co-founder. Zach Dweel. He did research at Intel, artificial intelligence research, and before that, he was the CTO of an energy analytics company called PlotWatt. So he spent a lot of time in the Bay Area and then came back to Indiana, mainly because he just liked Indiana and he could work remotely. And then he came up with the idea for this company a few years ago while he was in Indiana.
Got it. All right. Well, I'm a Wisconsin guy. I went to Wisconsin, so we got a
Awesome. Yeah.
little Big Ten rivalry.
Yeah, it's not a huge crowd of Midwest tech startups, so it's nice to just connect with you on that level alone.
Yeah, but it's been really resurgent in probably the last 5 years and even the 10 years. I mean, there's VC funds who we've talked to who focus primarily just in the Midwest.
Oh, definitely. Yeah, it's definitely growing. And close to Indianapolis is the closest big Midwest city to us, and they have definitely a growing tech scene. Salesforce has a bunch of office buildings there that they've been putting up. So yeah, it's exciting. It's an exciting time to be doing tech in the Midwest for sure. I think with construction tech or kind of like hardware in general, the Midwest has a unique advantage just because we have a lot of legacy. We have a history of heavy industry
Of
in the
course.
region. So and there are a lot of good engineers who live here. Mechanical engineers, electrical engineers, and we've been able to tap some of that talent at our company. But I know that generally speaking, that's an advantage that startups in the Midwest have if they're doing the hard tech.
And
Um,
and we know that there's a lot of problems to be solved in the legacy heavy industrial type processes and companies.
Definitely, yeah. Which what you're doing, even though what you're doing is a software solution at Materials Exchange, it's really exciting. I mean, it's a supply chain. It's there's so many supply chain problems that need to be solved, and it's pretty obvious that that software is a solution to a lot of those problems,
Yeah.
like the one you're solving with lumber. So it's really cool to see.
All right. Well, let's kick this off. It is Friday, April 1st, the first day of Q2. I cannot believe that it's already a quarter of the way through the year. Um, this is the Smart Market call, and I am very excited to have on. This is going to be a unique one. We're definitely twisting it a little bit, but I thought about the conversation that we had yesterday, and there's so many applications that are ancillary to just what you guys are doing, that I think this is going to be a great call. So without further ado, let's kick this off, and I am welcoming in live Terran. I'm going to show the website. Hello.
Hey, how's it going? Thanks for having me on, Mike. Very excited to be on the show today.
Yeah. So this is Nate O'Donnell from Live Terran, and give us the quick 2-minute deal on what Live Terran is, and then I know we're going to jump into really the nuts and bolts of your company.
Yeah, and just really quickly, our website is like liveterran.com, but our company is actually Terran Robotics. So I know it doesn't say robotics under our logo there, but just for a quick FYI to people who are watching, if you go to see the screen you're looking at right now, you can go to liveterran.com, LIVETERRAN. I'm the marketing director for Terran Robotics. I do a lot of other perform a lot of other functions at the company just because we are a startup. So I've done everything from soldering the electronics on our on some of the robotics to doing our bookkeeping and everything. But that's just startup life.
Of course.
But yeah, that being said, what we're doing at Terran is we're developing a robotic technology for essentially 3D printing out of a material that is variously known as adobe or cob, but basically it's clay subsoil mixed with aggregate and a plant binder, usually straw. So we are trying to turn dirt into affordable, sustainable, beautiful, comfortable homes. And like I said, the way we're doing that is by leveraging the most recent advances in AI and robotics. I can get into more details there as far as how we're doing that. We are taking an innovative approach, pretty much a unique approach, actually, where we're using a heavy lift drone. So a drone that.
Before we get there, right, let's go back to the thing I love about your concept is you're taking something truly ancient. I mean, when I say ancient, homes have been built out of adobe for long periods of time, long time ago. And the amazing thing is many of them are still standing. Like you can go see the ruins where there still is part of these foundations. So building out of dirt is not a bad idea. So let's just talk about that first. The actual product that you're building with, and really, why did you choose dirt?
Yeah. So really the company started from the perspective of, supply chain, and really asking the question of, what can we do to help reduce the cost of home building? Because ultimately our mission is to reduce the cost of not just building walls, which is what we're starting with, but ultimately to reduce the cost of building homes, through automation, but also through automation with the optimal materials. So, like I said, we took a supply chain perspective and we said, okay, of all the materials that we could possibly build homes out of, what is the lowest cost and what has the lowest environmental impact? And that kind of exploration led us to the conclusion that, hey, this material, this adobe material is a proven building material that is very low cost, but essentially has fallen into disuse primarily because of the labor involved. It takes literally thousands of hours picking up and placing it where it needs to be on the wall, or making bricks out of it. Either way, it's a very labor intensive process.
But the reality is the raw material for a structure you build could literally come from underneath the structure or next to the structure.
Exactly. And that is the ideal, sort of situation for building for our approach. So we don't have an exact figure on this, but we could estimate that roughly, 2/3 to 3/4 of the United States has clay subsoil that's suitable for this building method. So we could go to a construction site. We're digging the foundation, or we're digging a pond, a retention pond on a development, and we're using that soil to build the bulk of the wall. So yeah, you can see in the video here that's playing on the screen, kind of the showing the process, the building process. I'll get into that in a little bit here. But yeah,
like that, yeah, you dig it out of the ground, and then you haul it over, and you start making it into the building material. That sounds pretty inexpensive. There's no doubt.
yes, yes, and I should clarify, just because I know that your audience is focused on wood, on lumber, as a building material, and I should clarify that we see ourselves as essentially coming in to relieve some of the pressure that's essentially the demand pressure that's built up in the housing market. As we all know, like the cost of construction has gone up, and the cost of housing has gone up faster than incomes have gone up for people, and there's a shortage of skilled labor. There's lumber prices have been volatile. They've been spiking over the past couple of years, and so but that being said, and we kind of chatted about this yesterday, Mike. We fully anticipate that some people, not everyone's going to want a home that looks like our home, or that's built out of this material, or some people might want a home that's where the exterior walls are made of this material and the interior walls are framed, so that they can easily remodel. So I'm just kind of putting that into the conversation at the beginning, that we're aware of the fact that people want options, and we're trying to create a compelling
And you're a young company, obviously.
Yeah.
So all right, we know you're building out of dirt. You're building out of dirt because, number one, it's inexpensive. But what are some of the other qualities of a dirt structure that may not come to mind right at the first thought?
Yeah. So building with earth materials has a lot of kind of unique and interesting advantages. Probably the one that's most well known, and that's also pretty adds a lot of value for the homeowner, is that the walls have a high thermal mass. I mean, they're very massive, just in terms of tonnage to begin with. A typical 2,500 square foot, an average size American home. If we build all of the walls with this material, you're talking about roughly 150 tons of building material. So what that's doing is, for instance, in the winter, it'll absorb sunlight. If you have south-facing windows, you can have light coming in. You can do passive solar. Sun will heat up your walls from the inside during the day, and then at night it'll release that heat. So it acts like a thermal battery. It also acts as a buffer, so to speak, against fluctuations in outdoor temperatures. So as long as you're living in a climate where your high temperature and your low temperature are above and below your set point. So for example, if you wanted your indoor temperature to be 70 degrees and the high is 90 during the day and the low is 60, then essentially the high thermal mass will act, that 90-degree heat won't penetrate all the way through your wall by nighttime, and then it'll actually dissipate that heat during the night. So ultimately, there's, like I said, I think that the number one benefit to the end user is going to be the energy savings there. There's also a really interesting property of the material, which is that it absorbs and releases humidity in a way that kind of just, it's kind of coincidental that it's optimal for human health, but it keeps indoor relative humidity between 40 and 60%, with no with no assistance from an HVAC system. So it just naturally regulates indoor humidity. So those are two great benefits. And then for obvious reasons, it's soundproof, virtually soundproof. Just the thickness of the walls. We're talking about walls that are 12 to 16 inches thick, and then fireproof as well. These walls will not burn. I believe they currently have a 2-hour fire rating because they just didn't go longer than 2 hours in the test. But yeah, that's the fireproofing is another benefit there. So I could go on a little bit more, but I think those are the main benefits to the.
Well, let's go back to the construction method, because I think this is what's really interesting, and this brings in. All right, we've established that the The material itself has been around forever,
Yeah.
literally, but the technology of how to build this wall is new. So I'll click the video here. This is really pretty fascinating. So what are we watching here?
Yeah, I'll give some commentary here. So what you're seeing here, and just to kind of zoom out a little bit, as I mentioned, the whole problem with building with this material is that it's been very labor intensive to do so, and there's not a clear path to automating it. You can't pump it. You can't put this stuff through a pump. It's too thick. It's too it's literally dirt you dug in the ground. It has rocks in it. You can't just pump it. Even if you screened it a little bit, it has straw in it. Bottom line is, you can't pump it like concrete, and building with formwork is kind of cumbersome as well. So essentially, what we're doing is we're developing a technology that's using a drone to emulate the traditional technique for building by hand, which is literally, as you can see in the video, it's picking up a piece of the building material that's about a 10 or 15 pound chunk of the material, and then it's flying to where that material needs to be on the wall. It's following instructions that we're giving it, a map that we're giving it, and then it's dropping it and setting it down where it needs to be. And then as the video goes on a little bit longer, you'll see that's kind of step one of the process. Step two, which we're currently developing kind of in parallel, is this using this impact hammer tool that you can see that kind of vibrates at a pretty high speed, and sort of tamps and sculpts the material into whatever desired shape you're going for. And essentially, those are the only two mechanical actions that you have to take to build these walls. This wall, obviously, in the video, it has a plaster finish. The kind of finish you put on it is really up to your preferences and how much money you want to spend. Lime plaster is going to be a more expensive finish, whereas another option is to grind it and paint it. That's a little bit less expensive. Or you can just grind it down and seal it and have a kind of the more natural look. So it's really just that comes down to how much money you're trying to save, or how nice you want it to look. But yeah, hopefully does that give a good explanation, you think, of the basic process?
Oh, for sure. So you know what I saw when I watched the video here. It took me a couple times to watch it and kind of think through, but last night after we talked, I'm like, a drone on a job site is so applicable. Why does it, not only could you move Adobe, but you could move a box of nails. I'm sure we don't have nails anymore, but you could move materials on a job site using a drone, as opposed to having someone carry them up a ladder. Or, even if these drones become strong enough, you could set roof trusses with a
Absolutely. Or laying tile, or laying pavers for a driveway, or thing, anything of that nature. Yeah, anything. Basically, what we're developing is a general purpose solution. On the AI model and robotics side, it's sort of a general purpose solution for picking anything up and putting it down with pretty high precision. I mean, we're talking about centimeter and ultimately millimeter precision of placement. So absolutely, we're thinking about applications that are downstream a little bit, and as far as business models go, and licensing the technology, that's something that we don't have anything definite to say right now. But we're exploring ways of applying this to other building systems, and that might mean working with other companies to deploy other materials. But yes, that's definitely, you're correct. I mean, it's an obvious next step for us, and it's something that we are actively exploring.
I mean, think about even in a landscape application, if two workers show up with a truck and it has 25 trees on it, the two workers could go out and potentially start preparing the site and getting the holes dug for the trees, while the drone delivers the trees to each location. And then you have very minimal impact on site. For if it's an existing site, you wouldn't be rolling a wheelbarrow across or a trailer across the lawn. It's the whole drone idea, I think, is really, really quite fascinating. Are there any other robots that you guys are working on for this application?
We're not working on any other robots at the moment. Probably as far as engineering work that is in the pipeline for us. We are looking at potentially designing a custom custom mixer, since a concrete mixer isn't necessarily ideal for mixing this material. We might end up designing our own mixer. But in the future, like we anticipate designing other robots. We might do a rover that's on wheels. We're pretty open-minded, and really the drone is more of a means to an end. It's just for us, it's kind of funny saying it was the easiest option or the simplest option. It's kind of counterintuitive, but if you think about it, on this drone, we built this drone for about $25,000. It's a completely custom designed and assembled drone. If we were to build a 3D printer like you see in some of those videos online where they print concrete houses, that would be hundreds of thousands of dollars. So the drone, like I said, is really a means to an end. It's a low cost, very portable, but effective way to deploy this building material.
So I know one of the questions I had asked yesterday when I looked at this, and I'm thinking about how massive and solid these walls are. What about running, conduit or plumbing and stuff like that? And of course, it can be designed right in, and you embed the plumbing or electrical conduit into the wall.
Yep, it can be. So yeah, you could put conduit into the wall itself, or another kind of less radical option is to do a perimeter chase with the electrical, and then do plumbing in slab distribution for the plumbing. So just to kind of add that level of detail, currently our designs are based on using concrete slab floor, which is pretty suitable for this wall system.
Yeah, totally. It makes sense. So let's talk about the progress to date. Where are you at right now with the company?
So to give a little more context, in 2020 is when we really kind of got off the ground. Kind of late 2020, actually, we were awarded a small business innovation research grant from the National Science Foundation. So that was a $250,000 grant, and that funded us through the end of 2021. And then right about that time, end of 2021, we were accepted into a startup accelerator that's based in the Bay Area called On Deck. And that came with a $125,000 investment. So that's what's currently funding us. And I can't get into specifics, but we will be raising a seed fundraising round soon. And we're hoping that will kick off kind of a round of hiring to expand our team, probably move into a new location, but basically start to really speed up our development and start scaling up. So the video that you saw of the drone picking up and moving the building material, that video, we actually shot that video 2 weeks ago. So you're very up to date with where we are is in our tech development. Last summer we were literally bolting that drone together and just teaching it how to fly. And I know it sounds weird to say teaching it, but everything we're doing is based on an artificial intelligence approach. So the drone has multiple cameras on it. We're not using GPS or anything like that. The drone literally is making a 3D map of its environment, and it has to figure out how to get from point A to point B. And it has to learn how to fly while holding payloads that might be 10 pounds or 15 pounds or 20 pounds. It has to learn how to immediately respond to changes in payload and changes in wind speed, and correct itself and stay on course. So when you're seeing it kind of fly across the screen there and drop, pick up a payload and then drop it, those are all things that took months to train it how to do. So a lot of work has gone into achieving that basic operation. But now that it's learned how to do that, we're kind of off to the races, because it's sort of like copy and paste. Like if you can do it once, okay, now let's do it 10 times and let's build a small wall, and 100 times a big wall. So we're taking this AI first approach, which is pretty exciting, and we're very optimistic that by expanding our team and making a next generation drone prototype, we're really going to be able to do some exciting things as far as fast.
All right,
so that's really what the next 6 months to a year is going to be all about: taking this from the lab to the construction site and proving it out.
When can we expect to see the first Terran home built?
Repeat that.
When can we expect to see the first Terran home actually built on a site?
So we're hoping that this summer we will build our first home in partnership. It's a little early for me to be saying this, but I can go ahead and say we're hoping to partner with our local Habitat for Humanity chapter to build an affordable, sustainable home in our hometown, which is Bloomington, Indiana. We have we have several developers who are kind of we have lined up who are basically saying, like, once you prove out this technology, we want to do a small or medium sized development. Those will likely happen in 2023. So no matter what, I can say that we'll be building a home this summer. I can't guarantee I can't tell you exactly where it'll be, but we will build at least a small home this year, and then next year we'll be building at a larger scale.
That's so cool. So, I think this is such a innovative way to go old school, really ancient school is really what it should be,
Yeah.
and build an affordable house because we know that that's a problem that needs to be solved. The labor isn't there. Sometimes we're concerned about materials. So if you can solve a problem by using something that's currently available as material and bring in some sort of robot that you don't have to teach, it's already been it's already learned what to do. I think it's a really innovative solution. So, Nate, I wish you and the team there at Terran Homes the best of luck. Definitely stay in touch with us. I'd love to see a job site with about 7 drones flying around and not crashing into each other, of course.
That's cool.
Exactly. So, no, this is great. I really appreciate it. This is definitely not the norm of what we would talk about in the lumber industry, but that's what Materials Exchange is here for. Materials Exchange is we're changing the thought processes and changing the norm and showing there's a different way to do things. And hopefully innovation, automation will make everyone's lives better.
Thanks. Well, and I appreciate you having me on today, and of course, best. We wish you the best at Materials Exchange, and yeah, there's so many exciting things happening in the construction industry, in the construction tech sector. So yeah, let's definitely stay in touch.
All right, sounds good. Thanks a lot, Nate, and have a great day. Welcome to Q2 of 22.
Thanks.